this video, we're going to be looking at quadratic word problems. And I have a note page already printed out for you, so make sure you grab a copy of this, and we're going to fill this in. You should not be writing all this by hand. There's a copy of this for you. So if you need to, pause right here, and you can grab a copy for yourself. Okay, so in this section, we're going to apply these quadratics. They have a lot of applications. And mainly, we're talking about this idea of max and mins. So a lot of times, all quadratics either have a max or a min, and we can imagine that there's many scenarios where I might be talking about a max or a minimum. Like maybe I'm trying to find the maximum height that a ball is traveling. So we're going to look at this, and then we can use this example and kind of expand the ideas into other type of word problems. So a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t equals negative 16t squared plus 80t plus 40. So we're going to try to find when does the ball reach the maximum height. Well, if we're trying to find a max or min, which point on the parabola are we trying to find? We know that the max occurs at the vertex. So let's find the vertex. We have our vertex formula. X equals negative b over 2a. So we'll need to identify our b quantity and our a quantity. We have our a is negative 16. We have our b equals 80. And then we have our c equals 40. So we've identified our a and we've identified our b. Now it's time to just plug into our formula, and then we'll find the x value of our vertex. So I have x equals negative 80 divided by 2 times negative 16. So for these word problems, I'm definitely going to want you to use a calculator to help you solve these. That way we can be efficient with our time, and we're really just trying to figure out the answers, and so we don't want to get bogged down with the arithmetic. So we will type this in. We have negative 80, so negative 80, then I hit the negative button. And divided by, if I do 2 times negative 16, that's 32 negative, and I get positive 2.5. So I know x equals 2.5. So this gives me the x coordinate. I guess we're in t, so let's call it the t coordinate. So now I'll plug in my t value into my equation, and then solve, and I'll get the other coordinate of my vertex. So let's plug t in. So I have negative 16 times 2.5 squared plus 80 times 2.5 plus 40. So now I'm just simplifying. So I'll do 2.5 squared. So 2.5 times 2.5 equals 6.25. So I have negative 16 times 6.25 plus 80 times 2.5 plus 40. So I'll do these two multiplications. So we're going to do 6.5 times negative 16. It's going to equal negative 100 plus, I'm going to do 80 times 2.5. That's going to equal 200 plus 40. Now we combine on these, and we'll get 140. And this is the height that we're talking about, so we can say h equals. But all I really did is I just found a point. I found the point 2.5, comma, 140. Now, what does this tell us? And that's the key thing. Like, we do all this math, but do we have context for the point that we found? Well, typically, our x value, or our first value, the t value, is going to represent the time. And the 140 will represent that maximum value. And that maximum value, and for this problem, is the height. But it could change for any kind of problem. So we just have to make sure we answer the question in context. So this question is asking, when does the ball reach the maximum height? Well, I found the time that it reaches the maximum height, so I can write the sentence, the ball reaches the maximum height after traveling for 2.5. There's my value. And we have to use the units that were given to us. Is this in minutes, hours, seconds? And we go back and we go, oh, it's in seconds. So in 2.5 seconds. Now we can say, what is the maximum height? So this is when the maximum height, our time, and the actual maximum height will be our y value. So that is the maximum height. So we can say that the maximum height of the ball is, and we have 140, and what are our units? We go back to our question and we say, oh, well, we're talking about feet, so we know that the ball's maximum height is 140 feet. Okay, now the last part we're going to look at is figuring out when the ball is going to hit the ground. And I like using graphing tools to help us do this. We could do it algebraically, factoring and solving, but we're going to let a tool help us. So we have this point over here. That's that point right there. And how you're going to do this is, let's graph this first. So to graph it, we will graph using our equation that's given to us. But instead of writing t's, we're going to have to write x's. So we'll switch it to y equals negative 16x squared plus 80x plus 40. So we're going to want to type this into Desmos.com. So graph this at Desmos.com. When you graph this, you'll get this picture. Now the key idea is that I need to find my x-intercepts. So step 2, find the x-intercepts. And we can do that. You'll see that you can like kind of just hover over them and click on them. So we can click on this one and we'll click on this one and it'll give us the values. So we can see that value right there. So now we just have to think about what does this x-intercept mean? Well, this is a ball traveling. The ball starts at 40 feet high, it goes up in the air, and then it's coming down over time. And so right here, it's telling us how much time has passed, and what does it mean for the ball to be, for the y value to be 0? If the ball's traveling, then when y equals 0, we're talking about the height would equal 0 when we're on the ground. So our third part is kind of like think about what the x-intercept means. Well, what this x-intercept means is this is the time when the ball hits the ground. So I can write the sentence after 5.458 seconds pass, the ball will hit the ground. So I'm answering the question of what time will the ball hit the ground? Well, the ball hits the ground when my y value is 0, so I'm just finding that x-intercept. And I can say, well, after 5.458 seconds pass, the ball will hit the ground. And that's how we answer that. So I'm asking you to use Desmos to graph it, graph our equation that we're given from the problem, and then interpret what this x-intercept's meaning. So thank you for watching this video, and that's how you can use how we can use quadratics to help us solve these word problems.